Hello everyone. In this video, I would like to look at what is the mathematical definition of a group. Groups are actually very important in math, especially in algebra and modern abstract algebra. There's actually a whole field of math which is dedicated to studying groups and how they behave. So what the heck is a group? Well, here I have the definition of a group. A group consists of a non-empty set, G, together with a binary operation, which I'm calling star, such that the following properties hold. So, okay, well, what does that mean? So, it consists of a non-empty set. Okay, so basically, this set, I should say a set of elements. Very well, these elements could be numbers, but not necessarily numbers. So a set is just, it's a collection of objects, and it's non-empty. So there's something in there. It could be finite, it could be infinite, but it's some set together with a binary operation. And this operation could be addition, multiplication, something else. That's why I'm calling it star, just to be abstract. Star really could be anything, such that the following properties hold. Okay, so I want to go ahead and tell you one such group that we're pretty much all familiar with are the integers under addition. Okay, so what are these properties? Well, the first of which is closure. Closure. What does that mean? Well, it means that for any elements in this set, so if, let's just call them A and B, right? If A and B are elements, we're going to use this symbol here. That just means if A and B are elements of G. I'm going to write it like this. That's supposed to be a G. If A and B are elements of G, then A star B is an element of G. Okay, so looking at the integers under addition, right? If you take any AB, so any integers, right? So any AB that's an element of this group, then if you perform the operation on A and B, the operation here is addition, right? The integers under addition. So if you take any integer and you add another integer, what you're going to get is an integer. Always, right? You're never going to get some fraction. You're always going to get an integer. So we're saying that the set is closed under addition. So that's the first property that has to hold for this to be a group. I'm going to have 4 properties. That's the first one. The second is associativity. Associativity. Okay, what does that mean? Well, we're going to say for all, and we're kind of being a little abstract here, so I could use another symbol here. This upside down A just means for all. So for all A and B, for all A, B, and C, that's an element of G. Okay, we have what? We have A star B star C is equal to, if we just move the parentheses over, we get A star B star C. Okay, so what happened there? So now we have any 3, so A, B, and C, any 3 integers, right? If you add 2 integers, So let's say A, B, and C are, let's say 1, 2, and 3. So if we have A, B, and C are 1, 2, and 3, if you add 2 plus 3 plus 1, that's the same thing as adding 1 plus 2 plus 3, right? That's associativity, which is true when you're adding integers. We pretty much know that, but that's the second property which has to hold for this to be a group. The third of which is there has to be an identity element. An identity. Okay. What does that mean? It means there exists. There has to exist there exists an element which is normally denoted by E, which I don't particularly like. You know that E is a number as well, but this is E, the identity. This is not E 2.718. This is the identity element. So I'm going to call E. So there has to exist an identity element. We're going to call it E, which is an element of the group, which is an element of G. Okay, such that for any A that's an element of G. Okay, and if you do A star E, that's the same as doing E star A. So that's commutative. And what you get back is A. So, okay, so let's look at the integers under addition. Is there an identity element E? That this is always true? Well, I think there is. And I think it's 0, right? You take any integer A, pick 5. And you do this, you do 5 plus 0. That's the same as 0 plus 5, and that equals 5. No matter what A is, you will always get back A when you add 0, right? So 0 is the identity element of addition, of the integers under addition. So there exists an identity, and it is 0. And what is this last property? Well, there has to exist inverses. Okay, and what does that mean? It means for any A that's an element of G, there exists an element, let's call it A inverse. So we'll do this negative exponent. There exists an element A inverse that's also an element of G, such that you do A star A inverse. That's the same as doing A inverse star A. And what do you get back? You get back E. You get back the identity. You get back the identity element. So you pick any integer, right? You pick 5. What is the inverse? Well, it's negative 5, right? Negative 5 is also an integer. You pick 7. What's the inverse? It's negative 7. 7 plus negative 7 is the same as negative 7 plus 7, and you're always going to get back the identity element 0. So there are all of the axioms, you can call them, the main properties which have to hold, and what we get is this structure, this mathematical structure called a group. All right, I'm almost out of time, so I'll see you guys soon. Bye-bye.